In this video, we will be discussing the two-way chi-square test. This is a continuation from our one-way chi-square test. The formula is pretty similar. If you notice on your screen, we have the chi-square statistics is equal to a summation of the observed count minus the expected count squared divided by the expected count. One of the difference in our chi-square one-way and our two-way is how the expected values are calculated. In the two-way chi-square test, the expected values are calculated by multiplying the column total by the row total divided by the grand total. And we do this using what we call a contingency table. Later on, I will go through an example in which I will share with you what a contingency table looks like. Similar to our one-way chi-square test, we use the 7-step principle in order to carry out our two-way chi-square analysis. So the big question that I want you to bear in mind is, why do we do a two-way versus a one-way chi-square test? And that's simply because in the two-way chi-square test, we are looking to see if two or more groups differ on more than one variable category. If you recall, in the one-way chi-square, we were looking to see if two or more groups differ on one variable category. But in the two-way, we're looking to see how these groups differ on more than one variable category. So for example, if we wanted to examine if there is a gender or sex difference in the severity of depression, being mild, moderate, or severe among Georgia College students who are depressed, then we would use a two-way chi-square. Why? We're using a two-way chi-square because in the previous example, we were simply looking on the frequency of depression, yes or no. So that is one category. However, in looking on the severity of depression, we have three independent categories: mild depression, moderate depression, and severe depression. This is what it looks like in a contingency table. So in my contingency table, again, for my columns, I have men and women, and I have 20 men that are mildly depressed, 6 men who are moderately depressed, and 4 men who are severely depressed. On the female side, we have 7 women who are mildly depressed, 13 women moderately depressed, and 10 women who are severely depressed. What I want to be able to find out from my two-way chi-square test is if the frequency in each of these categories differ between men and women. So I'm not just looking to see whether the total number of depressed men differ from the total number of depressed women, but rather I'm looking to see if they differ based on the category or severity of depression. When I am looking at this, my rows and my columns that I will eventually use in my degrees of freedom calculation is only my men and women and the levels of depression. The total column and the total row is not used in calculating number of rows and number of columns. So step 1 of my 7-step principle is to define my hypotheses. My null hypothesis: there is no difference in the severity of depression by sex. My alternative hypothesis is that there is a difference in the severity of depression by sex. Step 2, I've defined my alpha and my alpha I've defined at a 0.05, which is the usual. I'm calculating my degrees of freedom. I have 3 rows, 1, 2, 3, and I have 2 columns, men and women, and so my degrees of freedom is going to be 2. Using this, I go to my chi-distribution table. I identify my 0.05 or my 5% probability column, and then I identify my degrees of freedom, which is 2, and using that, I'm able to identify my chi-square statistics critical value, which is 5.991. Now I can move to step 4, which is to make my decision rule. And the wrong table is in this, so please do not pay attention to this table. This is the wrong table. But the decision rule is that if my calculated chi-square statistics is greater than my chi-square critical value of 5.991, I will reject my null hypothesis. So how do I now calculate my expected values? If you look on the blue shape that is circled this first cell, you will see that my column total is multiplied by my row total. So my column total is 30. My row total is 27 for the mildly depressed among men. So again, let's do that. My column total among men is 30 and my row total among the mildly depressed is 27. So that is going to be 30 multiplied by 27 divided by 60, and 60 is my grand total, which is over here. I do the very same thing for each of these cells coming down, and then I do the same thing for women coming down. Take a moment, look at the calculation, pause the video if you must, and then you can move on to step 6. In step 6, I am now going to apply the numbers I've calculated for my expected to my formula, and my first column is going to be among the men. My observed is 20, and my expected, which I calculated in the previous step, is 13.5. So I'm subtracting that. And I do the very same thing all the way down for both men and for women. So this is the women here, this is the men at the top. Then the second step is to square O minus E. My observed minus my expected, I'm going to square that. So whatever this works out to be, I'm squaring it over here. And so if we take a look, these numbers in this cell represent the square of whatever the subtraction is from here. So for example, in this column, severe depression among men, 4 minus 7 is 3. Therefore, 3 squared is 9, and that's how we arrive at the 9. In my third and final column, I am dividing whatever I get in this cell by the expected count, the overall expected count for men. So my expected count for men is 13.5. So I'm dividing this 42.5 by 13.5, which is how I come by getting 3.14. I'm doing the same thing here, dividing 12.25 by 9.5, and this is how I get 1.29. At the end of all of this, I sum this column and I arrive at 9.24, which is my calculated chi-square of 9.24. Take a minute, review the slide, pause the video if you must before we move on to step 6. Step 6 is where we are now comparing our calculated chi-square to our critical chi-square value, which is 9.24, which is greater than 5.991. Therefore, we are rejecting the null. Our conclusion, therefore, is that the degree or severity of depression differs between men and women. And here we have our chi-square of 9.24, degrees of freedom equal 2, and our p is less than 0.05. And so this is a statistically significant test. Take a minute, watch the video over and over if you must to get the concept, because this is important. So in summarizing, what comparisons do we make when we use a chi-square? So when we use a chi-square, we're looking to test if there are differences in frequency or percentage by one or more category. And how does the one-way chi-square differ from the two-way? With our one-way chi-square, we're looking to see if there is a difference between our frequency and proportion on one variable category, whereas in our two-way chi-square, we're looking to see if there is a difference between our frequency or proportion on two or more variable category. That is it. I hope you are understanding the concepts identified here. If you are not, please feel free to contact me. I can go this over with you, as well as you can watch the video over and over again. You can also read the notes that are provided for you.